Let's consider another random experiment. In this case, we're going to be flipping coins that are biased. You might say, why do we care about this particular problem, like dice, coins? Well, I should note that these are not strictly about modeling these specific processes. The biased coin model could be used to model anything where there's a biased binary chance. So for example, could be, what is the chance that there's an earthquake next year? Or what is the chance that on January 7th, some bit in the memory of my computer will flip? Or this coming month, what's the chance that one of my hard drives fails in my server room? Okay. So I should note that Babak, who often teaches CS70, has said that if there's one thing that he wants you to get out of the discrete probability section of the course, it is this: understanding the biased coin model. Okay, so let's do it. So let's start by having the k equal 4 case. The reason I'm choosing this is it's still pretty small and we can play with it. But one of the reasons I like this biased coin model is it's going to allow us to go to bigger k's pretty quickly and develop some better techniques. But in this video in particular, we're just going to focus on k equals 4. So first question I have for you is, what is the chance if each individual heads is 1/3 chance and each tail is 2/3? What is the chance that we get 4 heads? The other question is, what is the chance that we get heads, then tails, then heads, then tails? That specific sequence. Again, I encourage you to pause and try and work it out. Okay, how about heads, 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 heads? Well, we can think about this tree diagram. I'm not going to show it big on the screen, but this tree diagram has a bunch of 1/3, 2/3 branches, and 4 heads is following the 1/3 branch 4 times. Okay, so it should be 1/3 to the 4th power, or 1/81st. And then we have heads, tails, heads, tails. In that case, you're doing 1/3 times 2/3 times 1/3 times 2/3. So that should be 4/81st. Okay, so those are the 2 outcomes we're thinking about. And if you'd like, I have here small on the slide a diagram that shows explicitly the tree, but hopefully in your head you can see it without having to physically look at it. All right. So those are just 2 particular outcomes. Let's talk about some more interesting events though. So what's the chance that all the flips are the same? Think about that. Well, it's just the probability of which particular outcomes. All heads are all tails. So we know that all heads is 1/3 to the 4th. We just showed that. And by a similar argument, all tails is 2/3 to the 4th. So that's going to be 17/81st. Okay. What's the chance we have 2 heads? Well, that's just going to be these 6 outcomes. And we want to know what's the probability of any of them. Like any of those outcomes, they're all going to be the same. They're all going to be 2/3 squared times 1/3 squared, which is going to be 4/81st. There's 6 of them, so it's 24/81st. Now this approach of manually enumerating all of the outcomes that correspond to the event, it will not scale, as we see when we get the larger k. But at this point, if you understand this, you're doing good in terms of having the foundations. And we'll see where the problem solving gets a little trickier in our next video.